See, all of mathematics beautifully begins with the zero we Indians invented, and then it progresses on to 1, 2, 3, the numbers, right? The beautiful numbers which you start counting with. So the number line was fantastic. You had 0, 1, 2, 3, and then slowly came the negative numbers because you went in the wrong direction. So there was direction for the number. It was beautifully symmetric on both directions, right? And these collectively, they were all called the integers. And once the integers were understood, they said, are there many numbers between 0 and 1? Yes, there was 0.5, there is 0.3, 0.33, point. There are a lot of numbers, infinite numbers. So you represented them using fractions and you call them rational numbers, or you had decimal numbers, you had 0 point something. This is a new class of numbers called irrational numbers. Why? Because the numbers go all the way to infinity and they don't repeat as well. So these numbers also sometimes can go to infinity. 1 by 3 is 0.333333, but they repeat. 22 by 7 is 3.1458714. It repeats again and again. But root 2 never repeats. So these are called irrational numbers. They can go all the way to infinity and they have special property, geometric properties from which they are getting derived. These are perfect numbers which you cannot see. All these numbers together, they are called the real numbers. Wow, real numbers? Are there unreal numbers also? We'll talk about that later. What is this? This is the number line where addition happens. So you jump in the number line in the positive direction. You go one at a time. You add. You go in the other direction. You subtract. You jump count. You jump 10 times. Counting 10 every time, you go to 100. So 10 times of 100. So jump counting is just multiplication, right, in the number line. And then what is this? This is division. You're just grouping things into equal parts. So you have 6 of them, you're grouping it into 2 equal parts, therefore you get 3, or you group it into 3 equal parts, you get 2 each, and so on and so forth. And then comes the geometric shapes. All these numbers are useful only to represent something real, shapes, right? So you can represent a straight line, some square of size 5, 4, 3, rectangle, circle. We'll come to circles a little bit later. This is percentages. Percentage is something that, a property of the number, of the original number, that you're trying to derive using some special meaning to give discounts, to compute taxes and everything. And then comes inequality. Numbers need not be equal to each other, but they can be greater or smaller as well. And then comes the world of algebra, where you start with the variable x, which you don't know what it is. You might square it, which means you multiply it by itself, or you can add 1 and square it. And then comes the understanding of what happens to x in the coordinate system, in the xy plot. These are graphs. And the graphs can later become three-dimensional also if you add one more axis to it, x, y, z. And the z-axis is going into and out of the paper, just like this cube here. And then comes the world of geometry, beginning understanding of angles. Where does the 360 degrees come from? It's from the earth rotating around the sun, 365 days, roughly 360. The angles inside triangle, the property of them, and the dreaded Pythagoras, who put a square on edges of all the triangle sides, and he has some properties. And then there are a lot of operations you could do with decimals, and that's with geometry, right? And then comes a qualitative understanding of volume, area, with different shapes that you can think of. And then properties of numbers, where you're saying least common multiple, greatest common divisor, some properties, some Euler properties, and slowly touching the polynomial area of algebra. So ax squared plus bx plus c, factorization, division, understanding how straight lines work, analytically understanding word problems with algebra begin, and then exponential understanding of how the functions are growing. So some functions can grow slow, some can go super fast, and some can make a parabola, some can make an ellipse, some can be looking like Earth, how it moves around the sun. And then comes the trigonometric applications. The properties of triangles are nothing but some ratios of edges, lengths of edges, and there are 3 different edges, and those properties are beautiful, understood in a unit circle, and some trigonometric identities of that is so beautiful. And then comes the statistics. Any numbers, you can have statistics out of it. You can add all of them divided by the number of entries, you give the average, median, mode, and you tabulate them, you derive patterns out of it. And sometimes even you can connect that to probability. What is probability? You have a toss of a coin, an event that you don't know what the outcome will be, putting a number to that, right? And then rolling dice, all the board games come beautifully here. And then understanding how those curves, the graphs can look with respect to the number of rolls, the number of outcomes that can happen. And then comes a deeper understanding of how these functions behave, f of x and g of x. And there is a domain for every function, and the function is sometimes continuous, not continuous, it has a value, or it sometimes does not have a value. And then comes the world of progressions. This is arithmetic or geometric progressions. These are some series of numbers which have some special properties among themselves, some of which is used in music, some kind of Fibonacci, petal counting, in plants, nature, a lot of other things. Understanding that in the context of sets and supersets are some kind of boxes in which you can populate all these numbers. And understanding combinatorics, because this is NCR and NPR means how many combinations of something is possible. This is game theory, chess, Ardupuliyattam, lot of fantastic things all come here. And then I'm introducing the beautiful complex number called I. So this, along with all the real numbers, they become the entire number space. Why is I important? Some property of cos theta and psi theta connected to I. And the matrices. What are matrices? You have matrix in 11 standards, where you actually put numbers in these funny way, and you add them, subtract them, multiply them, and you compute inverses of it, so that it is all suitable to be done in a computer hardware. And then you have the limit and continuity. You have some number which is going from one to another slowly, and it reaches finally, and to give you an understanding of what derivatives are, the chain rules in derivatives, and understanding the expressions of variables a little bit more with respect to logarithms and exponents, and then special variables called E, which is derived from continuity or exponentiation, and then understanding how it all connects to areas and volumes. How is area and volume derived? And it's beautiful connections to physics, because change means velocity, acceleration, displacement. Understanding change in the context of XY plot is very important to know when the maximum value happens, when the minimum value happens, when the change is a lot. And then comes all the beautiful series, the Madhava series from India in 1300, the Taylor series, and the foundations for how you can express pi. Pi is the most beautiful constant that describes every circle in this whole world with respect to the ratio of circumference to diameter. And why is that a number which never ends? If that can never end, how can any circle be perfect in the world? None of the circles drawn in this world is perfect. And understanding the coordinate system, the Cartesian or the polar coordinates, connecting it to vector algebra, and then comes the different derivative properties, integral calculus begins with simple variables, and then goes to trigonometric equations, and then the Euler understanding, Moore series, Maclaurens, and Laplace transforms and fast Fourier transforms, and AP calculus, the applied calculus. And I think we've almost covered most of the beautiful landscape. And where did it all start from?